All right, so we are starting chapter 4 by looking at what the graph of a quadratic function looks like. We've mentioned this already in earlier chapters. It's called a parabola, and I know you guys have seen it before. In earlier chapters, we had lines. Lines are super easy. You need to know how to plot 2 points. You connect the dots. It's a straight line. Doesn't get much easier than that. Parabolas, you've got a couple different features that you need to be able to plot and plot accurately. And so this first little piece right here, I'm going to walk you guys through kind of some of the vocabulary and the different features that parabolas are going to have. So when we are graphing quadratic functions, so first of all, this is a quadratic function here. F of x, remember that's our function notation. And this is the standard form that you guys are going to see whenever we deal with quadratics. Okay, so ax squared plus bx plus c. So first of all, just in terms of some vocabulary, like I said, you have 3 different terms that you can see here. So this is the quadratic term is right here. That's the x squared term. The linear term is right here. That's just the plain old x term. So this is what we had. Without this, this just looks like a linear function, just like a straight line. And then the constant term is this constant that's not attached to a variable at all. That's c. So whenever I refer to one of these 3 terms, make sure you know which piece of the quadratic equation we're talking about. So graphing it. Let me show you just what a generic parabola looks like. So I'm just going to graph parabola, something like that. Okay, so now keep in mind it could be shifted any which way. It might be flipped upside down, stretched out, but this is just kind of a generic piece of what a graph looks like. So 2 super important features that I want you guys to know when we're talking about a parabola. First of all is this point right here. This point is kind of like your turnaround point. If the graph is going down, that's when it turns around and starts going up. Or if it's upside down, that's when it's going up, turns around, and starts going down. And that point is called the vertex. Okay, so this one specific point right here, we call that the vertex. We're going to be using the vertex a lot. Every single time we plot a parabola, we need to know where that vertex is. And then next, see how this is a symmetric shape? This is a mirror image of this shape over here. And so I know you guys talked about lines of symmetry in geometry. So that's what this line is right here. If it was graphed perfectly, and mine is not, this would be a perfect mirror image of this over this line right here. So that dotted line that runs down the middle, we call that the axis of symmetry. Okay, so let me give you some formulas to find these things. So the axis of symmetry, in order to find that, we have a formula, and it is x equals negative b over 2a. Okay, so x equals, remember, always just ends up being a vertical line. And the vertical line, we get b and a right here. So b is attached to the linear term, a is attached to the quadratic term. We plug it into this formula, and that tells us exactly where the axis of symmetry is. So any parabola, you should be able to plug these values into this equation, and you'll be able to find this dotted line that we have right here. And x equals, remember, makes it a vertical line. And then for our vertex, your vertex is supposed to be an ordered pair. Okay, so your vertex, you get the x value from this, because the vertex is always going to be on the axis of symmetry. So you plug in whatever you get for negative b over 2a to get y. Okay, so you plug that in to get y. So the y value you're going to have to find, and remember the vertex should end up being an ordered pair. Okay, so the axis of symmetry, remember, is a vertical line. And then the vertex should be an ordered pair. So their x values are the same, but the vertex, since it's an ordered pair, it should also have a y value. All right, and then the last little feature you want to find is this point right here. That point's the y-intercept. Y-intercept is super easy to find. Remember, just like we did with lines, if we were trying to find a y-intercept, we plugged in 0 for x, so it's just as easy here. So our y-intercepts, you plug in 0 for x. So you'd have f of x equals, so it'd be a times 0 squared plus b times 0 plus c, so it always just ends up being c. So the y-intercept is going to be an ordered pair, and it's the point 0, comma c. Okay, so it's super easy. You can just look at it. It's just whatever the constant is, because if you plug in 0 here and 0 here, the only thing left would be the c. All right, so 3 very important points. And so I'm going to walk you guys through exactly how we would use these features in order to plot a parabola. Okay, so step 1, you're going to find the axis of symmetry. And the vertex. Okay, so you can kind of do that all at once. You'd use this formula to find the axis of symmetry. So the first thing you should be plotting is this dotted line right here. And then you know the vertex is going to be on the dotted line, so you can plug this in here to get an ordered pair. Then you'd plot the vertex. Okay, so far, all you'd have is a dotted line and then a single point on that dotted line. Then find the y-intercepts. So in most cases, you'll have this additional point so far. And here's an important part. Remember, we talked about how this is a line of symmetry, so anything that happens over here can be reflected over here. So after you find the y-intercept, what you're going to do is you're going to mirror that y-intercept over on the other side. And that gives you your third point. And as soon as you have 3 points, you'll be able to connect the dots and form that shape. So you're going to find the y-intercept and its reflection over that axis of symmetry. And then finally, you're going to connect the dots, make it a parabola. So connect these 3 points with a smooth curve. Make sure it actually is smooth and rounded. You don't want to make it pointed like an absolute value graph. It needs to be smooth and rounded. Okay, so let's look at this example here. So here we are, we've got a quadratic function. It's not quite in standard form, so just to make things a little bit easier, let's put it back into standard form. So x squared, we can think of that as like a 1x squared, and then minus 4x plus 2. Okay, so this is like our ax squared plus bx plus c. So a is 1, b is -4, and c is 2. So we're going to follow that step-by-step process. I've got them just written right out here so you can follow it. So find the axis of symmetry, the vertex, the y-intercepts, use this information plus that reflection I was talking about, and then we're going to graph the function. Okay, so axis of symmetry, I'm going to abbreviate here. Our formula is x equals -b over 2a. So we're just going to plug in these values. So -b, b already is negative, so it's like a -4, so it ends up positive over 2 times a. So this is 4 over 2, so that's 2. So our axis of symmetry is 2. So I'm actually just going to start plotting down here. So you go over to 2, 1, 2, and you plot that axis of symmetry. So that's going to be the first thing that you're going to want to lie down is that axis of symmetry. Then to find your vertex, what you're going to do is plug that 2 in, because the vertex is going to be somewhere on this line. We know that for sure. So we know that the x value is 2. We need to figure out what the y value is going to be. So for the vertex, you're going to plug in 2. So we want to find f of 2, which means plugging 2 into this function. Okay, so simplify this down. So I have 2 minus 4 times 2 plus 2 squared. Okay, so 2 minus 8 is -6, plus 4 is -2. So that means it's an ordered pair. So the vertex is 2 for x, which we found up here, and then -2 for y. So that's an ordered pair, and we can plot that. So right there would be our vertex. All right, and then last thing you were asked to find is the y-intercepts. Our y-intercept is super easy. It's always just the constant term. So if I plugged in 0 for x, these 2 terms would be gone, and the only thing that would be left is the 2. So if I plug in 0 for x, I get 2 for y, and that's my y-intercepts, which we can plot right there. That's the point 0, 2. Okay, so now last, use this information plus a mirror image. The last thing we're going to plot is that mirror image. So if you look over here, this is 2 units apart. So from the y-intercept to the axis is 2 units apart. So you're going to go another 2 units in the other direction so that you can plot a mirror image point. And the very last step is to connect them using a smooth curve. Okay, so that's your graph. So in the first video I mentioned that the vertex could either be the lowest point or the highest point. In this video we're going to learn how to distinguish between the two. So just as a reminder, I'm going to write our quadratic equation right here, just so I can reference back to the variables and the letters. So two things could happen. We've got two different shapes. All right, so we're going to have a shape like this. If A is positive, we'll have one shape. If A is negative, we'll have a different shape. Okay, so if A is positive, the graph will be right side up. All right, so it'll look something like this. Okay, if that's the case, the vertex is the lowest value. Okay, so in that case, if it's the lowest value, it would be the minimum. Okay, so that's if A is positive. If A is positive, it's right side up, so the vertex would be the lowest value. If A was negative, then our parabola would be upside down, something like that. And if our parabola is upside down, then the vertex would be the highest value. Okay, so that's this value right here would be the highest value. So also known as the maximum value. Okay, so two different things that you could find with the vertex, and it all depends on whether A is positive or negative. So again, it opens up like this, and it has a minimum value if A is positive, and it opens down like this, and A has a maximum value if A is negative. Okay, so two different shapes that you could be dealing with. So in this example, we are going to identify whether we have a minimum or a maximum. So this first step is pretty easy. Literally all we're going to do is look at this term, the quadratic term. If the coefficient is positive, then remember we have a minimum. And if our coefficient is negative, then we have a maximum. All right, so 4, of course, is greater than 0, so A is positive. And since A is positive, that means our graph opens up like that. And so when it opens up like that, we're going to have a minimum value. All right, so it seems kind of counterintuitive, like positive seems like it would pair with maximum, but picture what the graph looks like. So if you've got a positive value of A, we actually have a minimum value. Okay, so that's the first step. Again, kind of straightforward. You're just looking at that quadratic term and seeing what sign the coefficient is. So now state the maximum or minimum value of the function. When you are asked to state the maximum or minimum, what that means is find the vertex. Okay, so we're going to find the vertex. So our x-coordinate of the vertex, remember that formula from the previous video, it's negative b over 2a. So we can grab that right off of our equation here. So negative b, so b is this number right here, that's a negative 24. So a negative 24 becomes positive over 2 times a, which is 4. So we've got 24 over 8, which reduces down to 3. So that's not the minimum or maximum value. The minimum or maximum value would be the y value. So we find the x value, but then we need to plug it in to find the y value. Because when they say minimum or maximum value, they are talking about the height, which goes with y. So now that we know that the minimum value is going to occur when x equals 3, we plug the 3 in to our function. So remember, this is our function notation that tells us use this function f and plug in 3. So 4, I'm going to replace this x with a 3, minus 24, replace this x with a 3, plus 11. So order of operations, 3 squared is 9, 9 times 4 is 36, minus 24 times 3 is 72, and then plus 11. Okay, so 36 minus 72 is negative 36. If we add 11, we get negative 25. So that's the value that we're looking for. That will be the very lowest y value that your graph will hit. Okay, then state the domain and range of the function. Okay, so domain is all reals. Every single parabola, every single time, the domain will be all reals. That will never, ever, ever change. Okay, so that's always the domain for parabolas. The range, if we kind of do like a little sketch, we don't know what the graph is going to look like at all, but the one thing we do know is that it opens up like that, and we know that this y value is negative 25. So if it opens up and the lowest y value is negative 25, that means the y values that get hit are everything from negative 25 on up. So our range would be all y values that are greater than or equal to negative 25. So anytime you're dealing with a minimum value, your range will be greater than or equal to that minimum value. So vice versa for a maximum value. If you're dealing with a max, it will be everything less than or equal to. Okay, so do a quick little note for that. So if you have a max, your range would be y is less than or equal to whatever that maximum value is. All right. So example 4, the last one that we're going to look at here, this is a bit of a story problem. It says a souvenir shop sells about 200 coffee mugs for $6 each. For every 50-cent increase, he'll sell about 10 fewer coffee mugs. So we're kind of testing out like a supply and demand thing. So how much should the owner charge to maximize the monthly income? So we're kind of going off what we were doing here. We're trying to find the maximum value of the parabola, but since it's a story problem, we have to create our equation first. Okay, so our variable that we're going to define, x is equal to the number of price increases. Does he increase the price once? Does he increase the price 6 times? So we're going to set that up. So in words, looks something like this. So the total, like the revenue, the total cost is going to be the number of mugs times the price per mug. Okay, so kind of putting that out in words first. Okay, so the number of mugs times the price per mug. Okay, so let's use income as a capital I, so that's going to be our variable. The number of mugs. Okay, so here's how that is going to look. Selling 200 mugs, that's kind of the initial amount. This is like their standard that they're starting with. And then he thinks he'll sell 10 fewer coffee mugs for every increase. So it's going to be 200 minus 10 mugs per increase. So remember, x is the number of increases. So we start with that. And then times the price per mug. It starts at $6, and he's increasing the price by 50 cents. So plus 50 cents per price increase. Okay, so that's our income. Now, hopefully you guys love to FOIL, because we're going to FOIL this out real quick. So this equals 200 times 6 gives us 1,200. Outside 200 times 0.5x, remember this is half, so half of 200 would be 100x. Inside, negative 10x times 6 would be negative 60x. And then last would be negative 10 times positive 0.5. So negative 10, half of that would be negative 5. And then there's an x squared. Sorry, I was squeezing that in. Okay, so let's simplify that. Combine up like terms, and I'm going to write it in the order that we're used to. So the quadratic term will go first. When I combine these up, my linear term will be a positive 40x, and then my constant term is 1,200. Okay, so one thing you could think about, if there are no price increases, he's making $1,200, which makes sense. 200 mugs at $6 each. If there's no price increase, he'd make $1,200. But it says, how much should he charge? So we're trying to solve for x. So we are going to find the maximum value for this. So we're going to do it the same way we did up here. We're going to find the vertex and figure out what that value is. So x equals negative b over 2a. That's the x value. Equals, and we set negative b, which is the number in front of x, that's 40, over 2 times a, which is negative 5. So negative 40 over negative 10, negative over negative reduces to a positive 4. So the first question is, how much should the owner charge? So we're going to start with that. So 4 price increases means $6 is the original cost plus 4 price increases of 50 cents. So 4 increases of 50 cents would go up $2. So that means he should charge $8. Oops, that's off the page. He should charge $8. All right, so that answers part A. I have 4. This should make more sense. Okay, negative 5 times 4 squared plus 40 times 4 plus 1,200. Let's try that again. Okay, I'm sorry. So this, 4 squared would be 16. 16 times negative 5 would be negative 80. Plus 40 times 4 would be 160. And then plus 120. Okay, so negative 80 plus 160 would be 80. And then tack that on. So 1,280. Okay, so not going to be much more than we thought he could have made to begin with. So that would be our final answer after 4 price increases.